So again, welcome to today's session. We will be discussing how you can utilize ARM for greenhouse studies, or glasshouse is another term. Here in the States, we usually refer to it as a greenhouse. But I gotta go to my next slide here, just to introduce the idea for this session. It's a little different than a lot of our webinars where we just hammer on one particular feature that you can use in the software. We want to do something a little different, primarily because we get a variety of questions kind of throughout the year where a group has been using ARM, and within their company, maybe they have some greenhouse studies and they're not sure if ARM works with those. And so, the short answer is yes, you definitely can, but it's maybe not the most obvious up front. So we wanted to kind of collect all the little tidbits of tricks and tips and the various sections of ARM, how they would kind of lend themselves to these other types of studies. So, ARM itself, the software had started really in the crop protection. That was the very first type of research that the tool was made for, and then we just continue to iterate and generalize and kind of pick up more types of research as we build the software up. And so really it has become our goal to serve the industry. We're not just hammering on one thing, use it for that, and that's all we do. So as the industry has evolved over the years, we're trying to evolve the software as well. And that really brings us to a pretty good spot, I think, from just the software package itself, that, although there are really fundamental differences in research being done in a greenhouse compared to the field that ARM was typically, originally designed for. There really are pretty big differences in the research, but coming back to the software, it all kind of has a similar structure to it. And so, kind of fortunately for us, we're not trying to develop a brand new tool. Just about everything really comes in nicely and can be documented and used ARM for that other type of research. And we'll talk through all the kind of the different, like I said, tips, really a way to translate, if you will, kind of looking past a little bit of the terminology in ARM to see the purpose of that function and realizing, oh, that same purpose is useful in a greenhouse, even if it says something like your plot that, well, we're not talking about a field plot, we're looking at the pot that's sitting here in our greenhouse. Things like that while maybe the terminology doesn't appear on the surface like it would really work, it actually, the functionality is there and will be great. So that's the concept today. We'll have a couple of examples just to try to illustrate some of these points, but definitely if not quite hitting the target of what you do, what your group does with ARM, feel free to ask questions. And whether it's in today's session or if we don't really have time, definitely can reach out to us, send us an email in our support inbox, and we can kind of work through that with you and kind of try to do the same process that we're doing today with your specific research. Let's figure out how we can translate what we would need in ARM, or maybe if there is something we're missing, we definitely are open and willing and wanting to improve the software if there is something that doesn't quite fit, is a little different with a few tweaks, couple of additions in the software. Maybe it'll work great, which helps not only the group that's talking to us and we're working with, but then that can help others as well, which again kind of brings us back to our purpose of serving the industry. So everyone wins in those types of scenarios. So we really enjoy and encourage working with groups for things like that. Okay, well with that, let's just hop in to ARM. And what I'm going to do is just go ahead and create a new protocol. We'll just kind of start from the very beginning to talk through some of the differences as you would go through the general flow of a protocol planning into the trial, and talk through the different, slightly different items here. So usually kind of the first thing you do in a new protocol is looking at the protocol settings. And so we have our protocol checklist here, or we can open up the classic protocol settings dialog. Either one will work for us. And maybe actually I'll use this checklist to start with, just to see. Our checklist here is really just a set of the most common, most impactful settings, so you don't have to click through every tab and see all of the options. And just a quick glance to see that any rules, SEs or standard evaluations, replications, treatments, all of that information really is the same idea. But things like our study design, you might have a slightly different one, but nothing special to a greenhouse. But maybe we'll start here with the plot size as kind of one difference here. And actually, if I just click on that option, it'll bring me to our settings dialog, so we can actually look at and change these options. So starting with our plot size, as I said, the terminology here in quotes is plot, as that's the most common term in a field study, but certainly the more general fair term would be an experimental unit. And that's one of the biggest differences in a greenhouse study, of course, is what the experimental unit is. And it's going to be probably much smaller in size, and maybe fundamentally different as well. So you can see, with the width and length, it defaults to meters or feet, but there is smaller scale units. So you certainly could use this to document the size of your pot. That is your actual experimental unit. It would be important to do so if your treatment applications have any area calculations to them. That's really at the end of the day, that's the most important aspect to this plot size, at least as far as it's going to pertain to a greenhouse study. If our applications don't have anything to do with the area of the pot, then it's kind of irrelevant what we would set this size to. And so really in that case, if it doesn't really matter, I would almost just put in 1 by 1 or something, just to say, hey, we're really kind of referring to just it's maybe a single plant in a pot, so the area doesn't truly really matter. I'm just avoiding using a 0. I think a 0 could maybe be confusing, to say there's literally no size to our experimental unit. I think could be maybe a little confusing, but really kind of just a question of convention of what you would do there. If it doesn't matter, but again, it definitely is important if any treatment calculations as it pertains to applying our treatments, if that has anything to do with the area of a experimental unit, then we need to make sure to fill it in. One more thing to mention on the general tab here is the selection of our study definition, which is really just the template, the structure of the protocol and the trial itself. What fields do we have to fill in, things like that. And in most cases, the standard makes the most sense. and that is why it is the default. But if you are working in a variety study, and really this G seed, we refer to it as, is just a stripped down version of the standard. It's really taking out the concept of an application and really anything pertaining to applying a chemical. All of that is just taken out with the idea in mind that that's a lot of complication that wouldn't be necessary at all if you're just doing a variety study. So that's really the target there. If there is any sort of chemical, any sort of application that occurs with the treatments that you're studying, then you'd want to use the standard. So in most cases, this would be the way to go, but there is a chance, depending on what you're dealing with, if it's strictly varieties, that G seed might just be more intuitive. It'll have less extra stuff that really doesn't apply as well. But today we'll stick with the standard. The next section is our study design. And so just to kind of point out, we do have quite a few different designs that are supported in ARM. And certainly, I think the same ideas apply, whether it's a field or a greenhouse study, in your selection of things to consider for your design. But just to maybe translate a couple of these as far as it goes, comparing them from field to a greenhouse. The overwhelming usual selection in the field study space is an RCB design, because you can't control some aspects of the field. You might just be stuck with a certain gradient. And so the blocking is a really important aspect of that type of study. Whereas in a greenhouse, maybe you have a lot more control over some of those variables. And so it might be less common that the RCB is used. So you may also instead be more likely to come down to the completely random design, or the CRD. And that just does not have any blocking to it. So in a greenhouse, if it's just a bunch of pots spread out upon a bench, we have no reason, no specific restriction on where the plots should be placed. So it can be completely random. So that might be a common selection. You might, if you're on trays, perhaps, that have to, that are arranged in different locations, or maybe they're arranged vertically in a container of some sort. If there is any chance that different experimental units could accidentally, somehow be in a slightly different environment or situation, you might end up coming back to the RCB. So still some things to consider on what you're choosing, but ARM supports either one, and it'll really, everything will be the same in the study, other than when we're randomizing on the trial map, which we'll get to later on, the arrangement of the plots, and then also the analysis. Of course, the statistics is a little different in how we're breaking up the variance. ARM does have some factorial designs, some multi-factor designs, which maybe is of interest. We did actually just cover that in a previous session, so I won't hammer on them too hard, but I do want to point out the factorial CRD we added in the last year and a half maybe, and it was specifically from a request from for greenhouse studies. Because if you have a multi-factor design, you're arranging your treatments in a factorial type of way in how you've selected your treatments, but the underlying design, it's completely random. They can reside anywhere. that kind of specific combination lends itself to the factorial CRD. Whereas a few years ago, we only had the factorial, which was an RCB, which didn't quite fit. So there's a distinction now between the two on what the underlying design is, and in either case, you have a factorial arrangement of treatments. And then taking that one step further, if you can utilize the split plot if you have some sort of system for arranging the plots or your pots. So again, that idea of a tray or a bench, if you don't have enough space for all of the pots in the experiment to be on one bench, maybe you would consider a split plot for kind of grouping the way they are, which will actually be the example I used today. And I'll go kind of quick, like I said, since we did cover the multi-factor. I'll try not to belabor some of the specifics on the factorial designs. You can see in a little more detail in our previous recordings how those will work. But my example today that we'll just kind of talk through and fill in is a concentration study. So I have have this desire to test two different varieties, one that is susceptible to a disease, Fusarium disease, and one variety that is not, that's resistant, and wanting to see the difference. And really my concentration, I have different levels that I want to apply to kind of see that gradient of where is the magic level of how concentrated my product would be. So in that situation then, because of the presence of the disease, maybe my desire is to keep kind of on separate benches those different levels. So what I would do is my factor A, that first factor is the one that is being restricted, that somehow has the pattern of being separated, or all of the items within that particular factor are grouped together. I think the term grouping probably makes a little more sense there. So in my case, that would be the concentration. And I'll have a, the untreated, which would really be kind of a concentration of 0%, and then a low, medium, and a high. And so that ends up being a total of 4 different levels of concentration that I want to test. And for each one of those levels, I'm going to apply it to a resistant variety and a susceptible variety. So that would be my second factor. So all 4 concentrations will be put on variety number 1, and all 4 will be applied to variety 2. So I'll end up with a total of 8 different treatments when it's all said and done. So that's kind of how to fill that in. So we'll carry this example through so we can talk about the treatments, applications, things like that in this protocol. Hopefully it's not too big of a jump for other types of studies you might be doing, but that'll be our example we carry through here today. Now we have a few other tabs in the protocol settings. I don't think too many of them apply just yet. We'll kind of make our way back through here. We've got treatments. Not a lot is different here anyway. The application I do want to come back to, but we'll see that here in a little bit. And we'll probably also get to the layout section when we're randomizing. So kind of the number one target when first setting things up is let's make sure we have our study design set up the way we have, and we can always return to some of these other items. So I'll create protocol. And, oops, maybe our first thing to look at would be the protocol description. And I'm just going to display all fields here. So the protocol description, here we'll go through a couple of different tabs to point out things that are different. Of course, a fair number of these are really the same. We're performing research, so we've got due dates and categorization of what type of research this is. A lot of that should be similar. Not much of a leap is needed depending on what type of research that you're doing. But I do want to point out here in the Site and Design section on this first tab is where we can fill in the description of things like our experimental unit, which again, for a field study, this is maybe somewhat obvious. It's always one plot, and it is pretty self-explanatory, where suddenly in a greenhouse, this might matter a lot more. There might be more nuance here and things to consider. So we have an experimental unit to explain and define specifically what we refer to when, throughout the experiment, we're talking about that plot or the experimental unit. So I think I've got something like pot. We'll just kind of carry that on. You can be specific about what size if you need to. I'll just stick with the general one, but that's where you can define that. You'll see that our study design got carried over here as well. So that's a good one to draw out here, just to point that out. Otherwise, kind of big picture as we look at some of these items, and it fits really for anyone. A general tip on using ARM, especially people new to ARM, feels really overwhelming because there's just so many things on the screen, and I don't know what half of them are, and I certainly don't need some of them. A trick is simply that you have control over what you see on the screen. You can customize what we call the view. So if there's something that you just simply won't use, I think of something like your crop description tab is a good example, because there's fields for all different types of crops, different ways that you may be planting the crop or transplanting the crop, and things like that maybe don't apply at all for different types of research. And so you've got all these things on the screen, and it's way overkill. So things that just simply won't ever matter to your research, you simply can right click into that box and you can hide the current field. And you'll see that just removes it from the screen. Hopefully makes things simpler as you can just go through and hide things. So never use a nursery. I don't need to see that, so let me just hide that field. And you can just go through and simplify things down. You'll see it'll shrink. Even in our case here, the screen can shrink a little bit as we hide that whole row. It'll kind of shrink things down. So most especially for this other realm where maybe there's a lot of things that don't quite apply to the types of things you're doing, you can just simplify what you see. And over here on the properties panel at the right, you can see that there is a list of those fields, those boxes that you've taken away from the screen. So you can always bring back information if you need. We're not deleting the value. We're not deleting the ability to put in a nursery date. We're just removing it from the screen to simplify what we see. And it can always be brought back if you need. There's also, you can kind of formalize it one level up. as well. If you open up the view options, here it's got the list of all of the different fields that we're looking at and whether they're turned on or off. So this is another way you could go through and uncheck a bunch if you want to hide a whole bunch kind of all at one time. And when you have your selection of what you want to see and what you don't, you can save that selection to a file. So it's easy to toggle between different views. So maybe part of the year you're in the greenhouse, have those types of studies. So I want to use my greenhouse view, and then later on in the season, when we start to do field studies, I might have a different set of things I want to look at, and I can change what I'm looking at and save it as a named view. And then it's easy to toggle those even just from the properties panel here. Once you create one, it'll be in this list. I guess I don't have one created already, so let me save one here real quick. And we'll just say this is our greenhouse. Obviously, we didn't change a whole lot. So then if I come in and change, there's some kind of automatic views. This will make everything visible again. It's just a simple one click in this views to revert back to what I had saved when I gave it that name for greenhouse. And now that applies for all of the sections in the protocol description. And then there's a similar concept for treatments, assessment data, things like that. You can do the same thing. So hopefully that's a way to kind of get over that hump of having all of these different things that really don't matter for your type of research. Hide them all, get rid of those things from the screen so you can focus on what needs to be filled in. All right, last thing here in the protocol description would be the application. Another example where there's probably quite a few in this table that don't apply. But I do want to highlight these fields here, the application amount and the mix size. Those, at least in chemical studies, field studies, we spend a lot of time on these fields in our beginner training because it's important for setting up the application of those products out in the field. Depending on what you're doing, these might not matter at all, or it might be important. But in either case, we kind of want to fill them in. So using this little tool icon that's in the mix size field, we get this mix size calculator, which is really kind of that same function that we saw in the settings. But this is specific to our first application of the study. So certainly if you're going and performing, applying your treatments more than one time over the course of the study, you create several different applications for each one of those events. So the kind of the two big pieces of information that ARM might need, depending on your application, is your application amount, or your spray volume is another term oftentimes for that. And that is the rate of liquid, usually a liquid, where you have your product that you're applying with some sort of carrier. Like I said, commonly it might be with water that you're diluting that in, and then it goes out over your experimental units. So that's the definition here for that application amount. What is that rate? That not of the product itself, but kind of that one level higher when it's combined with its carrier. So by default, it has a per area basis because that's the typical thing for a field study. But if we drop down that list, there are a few other units that might apply more to these settings here. So if you've got like a potting soil type of situation, you can use the milliliters per liter. A unit like that, you'll notice it's not based on an area, but a liter of volume. If your carrier is for that potting soil type of thing instead of water, you could use your milliliters of that solution into a volume of things there. One other one to point out, there's a milliliters per item, which is kind of purposefully vague. The term item could be, if your experimental unit is, or the rate, I guess it wouldn't have to be just your experimental unit, but if your application is per plant, for example, I have a certain amount that I'm going to apply to a single plant, then that is a item. There's no basis for area. There's really not any calculation as far as that goes. It's just this much needs to be put onto a particular plant. And then you go by plant and put that amount on there. That's an example. So we've got that per item denominator, if you will, for the application amount. Otherwise, you might not have any use for this if your product is not diluted at all and it just goes straight on the item, then you really only have that product rate that would be in your treatments editor, and that's all that matters. In that case, typically I just recommend putting in a 0 for the application amount, and you can just leave the default unit liters per hectare or gallons per acre, whatever is common. But putting a 0 then just kind of makes it clear, since we do have to put something in. We could leave it as the default, but that can maybe lead to some confusion. Well, 200 liters per hectare, what are you talking about? We're in the greenhouse. That makes no sense. So I like to recommend just putting in a 0, just so it's kind of obvious that this isn't used. This doesn't end up mattering at all for the application of our products. Actually, let me just real quick put a value in here again, just to show that as we change that amount and as I was changing that unit, you probably noticed that this calculator is changing. So it's just trying to, based on the area we've given ARM and that rate, that application amount, it can try to calculate how much mix would be appropriate to cover that area. So again, that might not apply at all. So when we set that to 0, you'll see the calculated mix size then is 0. There's nothing that ARM can calculate to figure out the bare minimum that would need to be used, which is fine, because you can specify just a user-defined mix size instead. So similarly, there are a few different mix size units that can be used for different types of experiments. So if we're doing a per plant, that per plant example, you would want to use a mix size of units. So that would be then your mix size is really defining how much of that product are we preparing all in one go. And so in this case, you would be defining, well, I need to mix up enough to cover 50 plants or 20 plants. That would be one way, is to put in units as your unit for your mix size in that scenario. If you're doing that soil or potting mix treatment, then we do have cubic feet or cubic meters or cubic yards. So those volume units would apply for when you're applying something to a volume. like a potting soil example. For my example, where we're doing the concentration, we're just going to say the situation. I've got a 2-liter jug. That's just the the carrier, the item we use that I'm going to want to mix up my product with the carrier of water. So we'll just kind of fill that jug up most of the way. Then I'm going to ask ARM to calculate how much of my product do I need to achieve the concentration that I desire. And then we'll put that in to the jug and then top it off with water. So I've got that 2 liters in total. Kind of a real simple recipe, if you will. So I'll set my mix size to 2 liters in that case. And you'll see the highlight in red here. ARM is trying to leverage this calculation that it can figure out kind of the minimum amount you would need. And it's noticing that there's quite a difference between what I have chosen myself as the mix size and what it has calculated as an appropriate mix size. So in our case, we can just ignore that. It's highlighted to bring our attention to it, but we don't have to worry about it in this case, as we kind of investigate to say, oh, yes, that's because ARM thinks there's 0. So it's, of course, maybe a little bit confused. We don't need that calculation or that warning. I think that might pop up in trial validation as well, which we probably won't have time for today, but just to point out why things are being highlighted. And ARM will bring it to your attention, but it probably should be flagged just as a warning, which means, hey, pay attention, but if you know better, don't worry about it. It's not a critical issue once you review that. So in summary, we tried to cover a bunch of different combinations, but in the end, there's so many combinations and possibilities and all these different units and scenarios. It's kind of just playing around and putting different things in to see if how it will work in ARM. And that's a lot of the the process for me. Helping a group try to fit it in is a lot of trial and error of, well, if we try it this way, if we try it that way, let's see how we need to enter the information that we have in order for ARM to give us what we need. And that kind of ties into our treatments editor as well. This concentration example that I have took a few goes to get just right of how to have ARM, how best to enter it so ARM calculates the outcomes that we want. And so in my case, as we were talking about, I've got really 4 different levels of concentration. The first one being, nothing being applied, is just the untreated, but then a low, medium, and high level of concentration. And the product itself, initially we thought the rate should be I believe it's 100,000 CFUs per milliliter. And so we were trying to fit it into the rate originally, thinking that's our product, that is the rate for that product. But ARM just wasn't working for us. We were looking at the rate unit, didn't find quite the right combination to combine with our application, the way we described our 2 liters that we wanted to have. We really struggled with getting that to work. So the trick we devised was that our CFU rate, which again was 100,000, to put that into our formulation instead. So I've got my 100,000 CFUs per milliliter of product. as our formulation, and this is a liquid. I could be more specific, but we'll just keep it simple. If we put that as our formulation, then the rate can be our percentage, because in our rate unit, we do have a simple percent volume to volume. So our, kind of our initial thought, we're putting the formulation as the 10%, the low, medium, and high into our formulation. But because we didn't quite have the right rate unit available to us, we just switched it around, and it ends up working the same, works real nicely. So our low and then the medium, let's say 50% volume to volume, and then our high 75%. And I'll just copy down this information since it's all the same. And the untreated is kind of a zero, technically speaking. Wouldn't necessarily have to fill it in, but makes it a little more verbose, perhaps, of what we're doing. And then I will want to fill in the application code. So those are all linked to the application we defined there in the protocol description. And so then all 4 of those different levels of concentration, we wanted to apply to each one variety that is resistant to our fusarium and one that is susceptible. And I would probably be more specific if I was actually doing, maybe we'll call it resistant variety and the susceptible variety. Certainly we could document real information about this, the actual things that we were testing, but sometimes it can be just as simple as filling in your treatment name to describe what it is that that you're testing. For something like this, where there is no formulation, there's no application of that component of the treatment, it's not really necessary. So then real quick here before we move on, just to show the calculations then for those treatments, we can print the spray seeding plan. Oh, and wants me to save my study because it's a multi-factor. That's just fine. All right, so if I zoom in a little bit. So our spray seeding plan is going to show kind of all of our information here. In our case, some of this we don't really care about. That plot size is maybe irrelevant. The application amount somewhat irrelevant, but we do have our mix size. We care about that because that was the size of jug that we're going to use, and that is the basis for these calculations. So ARM can tell us what is the amount that of that product that we want to measure out. And you can see then just based on our rates, it tells us that for preparing our 10%, our low concentration, I need 200 mils of our product to go into that jug. And then I'll make a separate one for the 50%, that would be 1,000 and so on. And then these are the rest of those components. They don't apply, don't have an application to them. So they're kind of irrelevant there and left without an application code. So that's kind of our end calculation. And there's also product totals that just kind of sum up the total amount. In this case, the low, medium, high doesn't really help us to have the grand total of how much we would use. But that's okay. right, so I think that covers the treatments and applications about as well as we can, without just covering a bunch of different studies, kind of one out on top of each other. So the last real important section of a protocol to talk through would be the assessment data. And really, I don't think there's a huge difference with the assessments. Kind of all of the other areas in ARM, I think this one probably has the smallest difference. Of course, the actual assessments you may be performing could be, again, fundamentally different than what you might do out in the field, or they might not be too different. And the assessment section here, especially in a protocol, is just about describing the assessment that's going to be performed. So really the same ideas apply. You would focus in on your part rated, rating type, and rating unit. Kind of creates the core of the description of what is actually done. Your part rated being the object specifically that the assessment is performed on. So most generically, you would say it's just your experimental unit, but we'd want to be more specific. Am I investigating a single leaf on my plant? Am I looking at the plant as a whole? Especially in our example here with our disease, if I'm trying to count lesions or give a percent of infection, what is it I'm looking at? Is it percent of the leaves of the plant? Am I looking across the entire one? So that's a way to specify what object am I looking at. And then the rating type is the action that I'm performing. What am I doing, performing? Is it counting? Is it rating the severity of the disease? It's really the action the researcher is performing as this assessment. And then the rating unit is, of course, the unit of measure for that rating type of what was performed. I'm not sure if subsampling would be more or less common in a greenhouse, but it's probably just worth noting that if you do have a specific system for subsamples, so taking multiple assessment values for a single experimental unit in an assessment, that comes through as subsamples in ARM, and you can specify the system of how you are sampling. If you're going to take looking at 2 leaves on the plant, or whatever system for selecting the subsamples, there is a sample size. Then there's also a collection basis and reporting basis, just depending on how complicated that system is for selecting your subsamples. I won't go into all of the detail, but I do just like to point out that we have a help document. I'll actually go here under help and look at references. There's a reference PDF for describing subsamples. So that'll just bring up a PDF document, which was on my other monitor, and it just talks through a variety of examples of how you can utilize those fields in tandem with each other for different scenarios. Can be a little confusing. The descriptions of these fields that we get from SART are just really challenging to understand what they mean. So we try to have some story problems and explain how to use those fields. Question, possible to save a template only with the description of the assessment data. So yeah, that would be what we call an SE, a standard evaluation. So after you have filled in this header portion, the description of what should be performed, you can save that as a template. So kind of like what we did with that view file earlier, where you save it, you give it a name, it resides on your computer, and you can use it again and again. That is called an SE. Just real briefly, I'll just grab something off of these just to have something to fill in. You can right-click on that header you would want to save and export to an SE, again called standard evaluation. And that'll just formalize and save that description that you have so you can use it again and again. It's a really great way to, like I said, make that template. That way, that same assessment that action you perform again and again, you can make sure you describe things the same again and again. So great question on that. All right, so we are running out of time. I'm going to try to speed up. I've got just kind of 2 more little topics to point out. I'm going to create a trial. I forgot to fill in my trial ID. So when we're creating the trial, kind of the first step is the trial map. So obviously this is a little bit different in a greenhouse, but I think it still can be important to set up. Number one, so you can document the arrangement of your experimental units. In this case, instead of out in the field, how they all are close to each other, spatially speaking, it might be more about how they are arranged on the tray or on the bench. But it can be important to document that, especially if, in our case, with our concentration, I maybe want each one separate. I need to make sure that the lows aren't too close to the medium if I'm worried about any drift or the differences in what might occur because they are close together or separate. Maybe I need to keep the varieties totally separate. It just depends on your type of research. And remember, that was the choice for the split plot, is that I had a requirement to segregate the, in this case, we chose the concentrations. So they should each be on a separate tray, if you will, separate area on the bench, maybe. So that's what's been done here. For each replicate that I have is basically a row here in this table. We have the concentrations grouped together. And if I pop into the settings here, I've got layout options. I'm going to not randomize the concentration to give a nice pattern to my map. So I've got all of my untreated together, spatially speaking, which might be all on one tray, or at least on the far left side of my bench, whatever. And then the next level and the next level down the bench there. So this trial map can still be important to document the spatial aspect of where these plots are. It just might not be quite the same concept as out in the field. Maybe each one of these replicates, each one of these rows is a different tray in a cabinet where they are stored. So it might take a little imagination on what this looks like, that it's not literally a field, but getting that spatial aspect down can be important, especially if at the end of the research, maybe there is a concern of whether spatially something was affected. Having this map correct can allow you to dig in to some of that and see if there's any interaction or something. So once I accept that randomization, then I am in the trial. And just to point out, we've talked through the protocol description. Quite a bit of that comes into the site description. There's some fundamental differences. Maybe your GPS coordinates matter a lot less, but you still probably have GPS coordinates for your greenhouse location. So that's maybe you would fill in just that general location, and that's where maybe your accuracy can you can point in that it's not as important compared to a field where you need to have everything geolocated. So some things you might still be filling in, but there's just a slightly different reason for it. I do want to point out, relatively new to ARM, a section in the site description specifically for greenhouse. The idea being it's basically the equivalent to the weather tab, but for greenhouse studies. So you've got maybe different environmental things to record. So instead of sunlight, that you have absolutely no control over how cloudy it is or not, and you document how many clouds are out there, instead for a greenhouse, let's document the intensity of the light that we have on the plants and how long those lights are turned on. So there's just fundamentally different, see if there's more fields here. No, that's about all. Different things that you're wanting to document. So this, you would just have a different row in this table for every day that the research trial is performed, and you can just have all of that documentation there, specific for this type of research. Really, any controlled environment, you can document that information. And there's also a new equipment tab, which I think would we try to be very vague, so there shouldn't be anything too specific for field studies, in hopes of being able to document any sort of equipment that you're using, especially for assessments, but for really any part of the study, you can fill them in here. But otherwise, all of that information about our application, actually those details are in your application equipment, so that got copied over. You can still do your spray sheet and all of the usual things there. But outside of that, then, really moving through the rest of the study, that, taking of the data, the analysis, kind of everything from that point on is very similar to field studies. I think those are really the big differences, is maybe what you're filling into the site description, and really all of that views and the things that we looked at in the protocol description apply here in a trial as well, about hiding fields and documenting things. Same concepts. And so I don't really have the time to cover it, but hopefully it's pretty easy to jump across those ideas there. So that's my time. If you were holding on to questions to the end, I apologize for being a little long-winded, but definitely reach out to us if you have questions, or like I said, maybe you've got a protocol that you have just not quite sure how to get it into ARM. Contact us. We can kind of try to talk through it, see what twists and turns we need to do to get it into ARM and give your calculations and whatever you need. So with that, thanks again for joining. Another just friendly reminder, if you are joining us next week, we've got that time change, but hope to see you again at a future webinar. So thank you.